She's
the older one?
Mm-hmm. She has a personal trainer.
Oh,
She's in the yet. Because her friend lost all this weight, and I knew because my little sister told me. And I was like, I wonder how so-and-so lost so much weight. She looks so good. And she's like, yeah, she's got a personal trainer. Da 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 da, but she didn't tell me. And I was like, oh, you little bee.
So the camera's on.
so nice
It's all
sensory.
recorded. This is blackmail.
Cut me out.
All right. So thanks, ladies, again for meeting today. And what we're going to do today is go over a teach back. And so we haven't practiced this protocol yet, but I'm excited to try it with you guys to see what insights you have with it and to get your feedback on it too. So let's see. I think what we'll go over first is just I'll just talk about what takes place before the teach back happens, just to show you like what I've done here. Basically, what I've done is I've selected a lesson that I thought could be useful for all of us, because all of us are science teachers, and all of us do explorations or labs where there's some kind of data gathered, and then we want to have discussions with our students around that data. So what's wrong with the data? What does the data reveal? How does the data back up some sort of law or concept we've been studying? So I've chosen one around the law of conservation of mass. So basically, before a chemical change or reaction occurs and after a chemical reaction occurs, the masses should be the same, as you guys are all aware of. So no mass is created or destroyed, no atoms are lost or gained in the process. They just break apart and form new chemicals, as you are very aware, Heather, because you have taught this before. Have you guys taught 8th grade or that concept before?
It's also in 5th grade.
Yeah, But
No.
you guys, I don't think I've touched upon it. Okay.
No,
so
but
that's
I
cool.
remember.
Yeah, you guys, you know.
It's been a while, but it's in there.
Yeah.
You're like, I know. So basically, I've put together the lesson plan that I would teach to go along with this lesson, and then student data. So since I've done this lab like a few times, what I've done is I've taken like student data that I've seen or just patterns I've seen in the class, and I've put it on the screen, and then we'll actually practice discussing it with students. You guys will be the students, or you'll be the teacher, and the rest of us will be the students, and then we'll do like a mock discussion. So let's see. The classroom is free so that no students are going to be in here disrupting us, hopefully. For the launch, what's going to happen is we are going to review the norms first. So I'm under the launch category, so this is like during a teach back, what happens during it. Right before we should review norms. So the norms are these. Would someone like to read the norms for us?
Sure.
Go for
Norms are reviewed include number one, everyone participates as much as time will allow. 2, no stopping or redos, keep teaching. 3, no side comments or explanations, keep teaching. 4, incorporate previous feedback into your own teach back. 5, we'll make tons of mistakes, that's the point of practice.
There will be a timekeeper who's assigned as well as a note taker for the meeting to make sure the meeting stays on schedule, and any necessary any necessary next steps are detailed. So does anyone want to volunteer to be the timekeeper? What we'll do is we'll teach in like 5-minute increments and then pause and like reflect on those 5 minutes, and so that person would just be the timer for that.
I will, because I'm facing a clock.
Oh, wonderful. Okay, sweet, and that's easy to count, the 5 minutes, okay.
Oh yeah.
Does anyone want to be a note taker who will like write down what feedback is given after the 5-minute increments of teaching?
I do not have a pen.
I can't. I think I have a pen.
If you don't have an extra tip.
I have 2.
I'll take one.
So let's do this. Okay.
It'll be faster.
So this is what's going to happen during the meeting. Could I have, Morgan, do you mind reading the steps for meeting content?
Leaders will walk teachers through a basic overview of the lesson that includes the main idea of the text being studied, the primary objective of the lesson, and potential student misunderstandings. Sufficient time will be given to teachers to review, prepare, and ask clarifying questions on the lesson after initial review. Teachers take turns teaching a small but important piece of the lesson, roughly 3 to 5 minutes, with other teachers serving as students and providing a variety of answer types. Often the leader secretly assigns roles to the students for this. Leader provides targeted feedback to the teacher, specifically addressing the teaching focus of the lesson and progress towards excellence, 1 to 2 minutes. Leader reminds subsequent teachers to incorporate previous feedback and work toward exemplary performance with each teach back.
Cool, thank you. So, after we read through the protocol, I'm going to explain the lesson to you guys and like what exactly are you looking at, and then I'll give you time to look through the lesson, to look at possible student responses. I'm actually not going to select or plant any students to be like the one who doesn't get it, right? I'm going to let you guys flow with the responses I've put there, because I've put some misconceptions in there too, or things I've heard students say before that like I would have to address, or I would have to get a student to address. So I'm not going to plant anybody. We'll just kind of flow as if we were all 8th grade students. For the wrap-up, could you read that, Ms. Rivas? How are we going to wrap things up today?
Wrap-up includes a reflection by the team on the progress made towards the stated objective of the meeting. Teachers should share their individual perspectives on what they learned through conducting teach-back. Leader directs the meeting in accordance with planned timing to ensure that there's sufficient time for questions and checks for understanding. Leader summarizes the areas of instructional focus that were rehearsed, as well as any other instructionally relevant takeaways from practice session.
Cool. All right. So, any questions just on the protocol? Oh, the follow-up. Any noted takeaways or steps are included in a follow-up email to the team that includes due dates and clear lines of responsibility for each item. Leader sets her schedule to observe teachers implementing instructional moves or lessons covered in the meeting. If appropriate, student work collection is also scheduled. If appropriate, student work collection is also scheduled to best determine effectiveness of teach back. So like let's say we talk about, like obviously we're talking about discussing data today, and part of it will be using habits of discussion as well. So if we all agree to it, when I go and observe you guys in the future on a post-lab day, like I would expect to see some of the things that we came up together implemented in your teaching. Yeah. But we're going to come up with those ideas and those best practices together. It won't be me being like, this is how I want you to do everything. In fact, I actually really want feedback on this lesson because this is the way I typically do it, and if there's a better way, I want to know what you guys do in your class. So, for the lesson today, I'll give you guys the overview. I already told you it's about, the standard is that students know that the idea of atoms explains the conservation of mass. In chemical reactions, the number of atoms stays the same no matter how they are arranged, so their total mass stays the same. This lab is to, what we've done so far, or what students have already done, is they've already done molecular model activities where they've actually had molecules and they've broken them apart and rearranged them as they would normally happen during a chemical reaction, so that they see that the number of atoms before stays exactly the same at the end. So this lab is a follow-up to show like what does that look like in real life. So let's actually weigh all the materials in a reaction. So this is the classic baking soda and vinegar lab. So they weigh the glass flask, they weigh a balloon which is meant to capture the CO2 that's created. They weigh the baking soda and the acetic acid, and they weigh it before the reaction, then they just tip the balloon over, the baking soda falls into the acetic acid, the balloon inflates, as you can see from the pictures here, that's part of the hook. Look at you guys. Those are some of my old students, by the way, so that's why they don't all look familiar.
Nice
who are those
tables.
children? Yeah, oh, I had a lab and everything. You guys, I had it good. Then I came here. No, just kidding. Just kidding. We love prep. We love the facilities.
Who's gonna watch
Cut
this?
that out.
Carlos?
Maybe Carlos, yeah. Anyway, the balloon inflates, it's supposed to capture the gas, and then they weigh it. I asked them to wait a minute so that like things react, they swirl the reactants around. Then they weigh it again and calculate the mass or record the mass, and yes. Now, theoretically, according to the law of conservation of mass, if they started with 138 grams, they should end with, everyone?
138 grams.
Right, but I actually make this lab flawed on purpose to see if they actually get the law. So as they wait for a minute, gas is actually able to escape from the latex balloon because latex has these small pores within it, which is why latex balloons, if you have helium-filled balloons on your birthday, the next day they will be on the floor because the helium would have been allowed to escape through the pores overnight. So it actually begins escaping in that 1 minute that they're waiting. And so if you look at the data, a lot of the data shows that the mass is lower after the reaction. And so that puzzles the students a little bit, like why I thought the law of conservation of mass is the masses are supposed to be conserved, they're supposed to be the same. So that generates a discussion on like what's actually happening here. Is the law of conservation wrong, or is there something wrong with our lab? And how come there's a pattern? How come so many lab groups are showing a decrease in data? There's something like systematically going on here. You know? So that's like the purpose of this lab, and to really get like, do they get the concept of law of conservation of mass as seen in real life? So I'm going to give you guys a second to read over kind of the way I typically do this discussion with my students. You do not have to memorize this script when you do your teach back. Basically, this is like my framework for how I question them, and you can mess around with it and see what the students do with it, and how, if there's another strategy that seems to be better. I included, this would be like the lab data. So that's one of the slides on the screen as well if you want to refer to it. And then the actual lab is on the last 2 pages. We're not going to get into writing ACES paragraphs today because the point of this lesson, if I go back to my objective and read it real quick, the objective is by the end of the lesson, all students will be able to summarize whether their lab data violates or obeys the law of conservation of mass, and if lab data is inconsistent with the law of conservation of mass, students will develop logical arguments as to why the lab data is not consistent with the law. So I'm trying to get them to generate those explanations, and that's the point of the lesson. Any quick questions before I give you guys time to read over? Okay, cool. So,
So you talk about, you talk about helium escaping from a balloon, so you give them that example, like what happens when you...
Well, in the, not initially.
Okay.
So I want to see if they can get to that conclusion themselves, and see if they can think deeply about what they were actually using during the lab and why that could have distorted their data. So I'm hoping that they get to it on their own, but if not, I give them a little seed. Like, let's think about the latex balloons or the helium, or just even the balloons themselves. Yeah. So I'll let you guys go for, we'll say 3 minutes.
The science team, the great science team. Yes.
I just came for my coffee.
Yeah. It is one of those. I think you're on the left.
Clearly.
You might have to read it though. It's
They all say
it's
Sarah.
Choi.
Oh, like they're
chai
in
soy.
there?
Yeah, you might have to remove the little
A lot of
wrap.
people got those, huh?
Yeah, we're a very like chai
I love chai.
school. Yeah, everyone wanted chai.
Well,
I love
can't-
chai.
Chai soy, that's it. Okay.
Yeah.
I can't drink coffee anymore, so it's not.
Yeah.
Feel your pain.
Yeah.
Oh, is it like
Are you
a-
sure you don't want to join us?
this?
Huh?
Are you sure
Do
you
you guys
don't?
want me to? Then we're gonna have to find more
She
coverage.
has a job to do. She has a job.
Good luck with your job. Oh yeah, is someone covering all our classes? Do we
Yeah,
people
it's all
covering?
done. Yeah,
Okay.
Ben, Andy, Elvia.
Oh nice.
Question. Is the attendance in your room already?
Mine?
Yeah.
Yeah, it's under my overhead.
Okay, alright.
You're okay with her taking attendance?
Oh yeah, absolutely. Yeah. Yeah.
It's trustworthy.
Yeah, she
Yes.
is. I'll give you guys like another minute to look it over.
Do we know which parts, like who, so we're just gonna like jump in and start, or do we know, like, is there an order that we're gonna teach? I'm a little confused.
Yeah. So yeah, let me break it down a little more. That's a good question. I'll do the first. I'm actually gonna break it down to just 3 minutes. So if
Okay.
you could watch for 3,
Mhm.
you could just be like, stop, you know.
Is it just the guided practice?
Yeah, just the discussion. So just, I'm skipping the hook, forget about
Mhm.
the pictures. I'm gonna start right here.
Yeah,
Yeah.
okay.
So I'm gonna teach for 3 minutes, and then no matter where we end in the discussion, like, I'm gonna stop there and get your guys' feedback. And then what you can do is decide, like, I think it might have been better if it went like this. And then if we decide, like, there's a better alternative, then maybe I'll have you, Morgan, get up and actually redo that teaching portion. So you'll start again from the very beginning of the guided practice, and then do those 3 minutes again, but with a new strategy.
Okay.
If we decide, like, yeah, like maybe I would have done a minor tweak here, like we would write down that feedback, but we don't have to redo those first 3 minutes. We could just continue on. So that's when, like, maybe Ms. Rivas will get up and she'll continue from that stop point
Using that feedback.
with the rest of the discussion. Yeah, especially if it's feedback that she can apply to the next 3 minutes.
Okay.
Yeah.
Thank you.
So-
I have a question for you.
Yeah.
Do you have any yeast?
Hold on.
I think I might have some.
I think she does. I didn't use any last year, so I don't.
Borrow some today.
Yeah.
Okay. Because
Yeah.
I bought a jar and it's sitting on my cabinet, and I'm like,
At home?
yeah, I'm doing a cellular respiration lab today for the
Oh, yeah,
kids
yeah.
because it's really hard for them to understand, like,
That's fine.
so I'm gonna do it with yeast.
Do they do the
I
balloon
think I
one
have
too?
some. Yeah.
Not with the balloon, just so they see it bubble, so they know some gas is being released. And I have the sugar, I have the warm water, I have everything but the yeast. Thank you.
I think I might have
Okay,
some. in my
perfect.
cabinet.
If you do.
Because I did that last year.
Can I borrow 8 beakers?
Yes, take them.
Okay.
Oh wait,
I
beakers,
just
yes.
remembered.
I have, we're using only 6 of them today, so I should have 8. Some might be different sizes.
That's
Do you mind?
I think I have
I have the
beakers
little
too,
baby ones
and I'm
too.
not using them.
And I have these jumbo ones that like Ms. Hirsch gave me. Oh, I spit on you, sorry. They're like 500,
5,000.
5,000, yeah.
That's
They're giant. I used them as,
all little, like,
I got them as a
all
donor
the same
choose,
size
like a
little
couple
ones,
schools
this big
ago.
one?
Yeah.
And I have some nice ones.
I use
that
them
are,
as the like
Oh, we
dump
don't have to.
bin, so like when we're doing
There's gonna be
like
sand and water in
a
it.
cabbage lab
Oh,
with
cool, so you
acids
can
and
make
bases,
some sticky ones.
I
but yeah,
get
you
the
just
big
go
ones
in
because
the
they can
cabinet,
keep
they're
pouring
also
things
right
in
there.
again and again to see the color change. So I can do the lab multiple times, and when they're done, there's one for the waste, so I don't have to empty them
Yeah.
between every class. I can just let it go for the day and then empty it at the end. Because I'm lazy.
So just to reiterate, you guys are the
Yeah,
students. You guys are, since there's just 3 of you, you guys would like think, pair, share with each other, like fake think, pair, share with each other. And then I'm gonna like cold call, obviously, you guys in a random order. That's so like when I do that. Though I script a lesson, sometimes like
Yeah,
most
yeah,
teachers,
yeah.
there's a little wiggle room, so.
Yeah.
Sorry if I throw you off, but just kind of roll with it, like the norms say, like, I say like a lot. As the norms say, we go with the flow. So if I make a mistake, it's fine. I'm just gonna keep going as I would, as I'm teaching. Okay. So are you're cool with doing the 3 minutes?
Yep.
Okay. You don't need my phone? You good? Okay. Alright. Here we go. Thank you, students, for yesterday's lab. Here are some photos from yesterday where you guys did the lab, and I just want to thank you all for being very, very careful with yesterday's lab. No glassware was broken. As I was monitoring, I really noticed you all were taking data down very carefully. You were making observations in a serious way and really gathering data like true scientists. So thank you for that. Yesterday, I went around and I took pictures of data that you all were gathering. So this is true data from our class from period 2. And I just want us all to take a second and look at this data because I noticed some interesting things about it, and I think that you all will notice it too. So I want you to just take 20 seconds to yourself and look at this data closely and see if you notice anything interesting about the data. Okay, 20 seconds are up. Partner A, I want you to tell partner B any patterns you notice in the data or anything interesting that stands out to you. And then partner B, partner C, I want you to share what you found as well if it is different than A. Go ahead and take 30 seconds to share.
I see some decrease in before the reaction and after the mass has changed.
Except 2.
Yeah.
One stayed the same and one is bigger.
Yeah, I agree because all 3 on the left decreased by 1 unit and one stayed the same, one decreased by 2 units, and yeah, the other one, the one that's interesting is the one that got bigger.
Okay, our 30 seconds is up, so I'm going to start just calling on students to hear what you discussed with your partner. So Ms. Rivas, what do you notice about the data?
We noticed that most of the data decreased except for 2, one that stayed the same and one that increased. And we thought that was pretty interesting that one increased significantly.
Interesting. Thank you for sharing. Ms. Hirschberger, can you get specific about what Ms. Rivas just said? Can you, I'm gonna be up here circling things, so can you tell me what data points she's talking about specifically?
Yes, so for the first one, it started at 138 and it went down to 137 grams, so it lost a gram. And actually all of them in that side lost a gram, 137 to 136, 141 to 140. And then the other one that decreased was 140 to 138 on the right hand side, and it went down by 2. And then the other one stayed the same and got larger.
Oh, interesting. Okay, I'm going to use a different color.
Okay.
And which one did you say increased or stayed the same?
The one top right, 140 and 140, it was the same before and after.
Okay.
Can you choose blue?
Oh,
The next
yes,
one?
let's change. Oh, for the next one. Yes, yes, yes.
And then that one went up 120 to 138, which is an increase of 18.
Right. Thank you for being specific. Okay.
And time.
Oh, wow. That was fast. I actually thought I would be able to get through some more. Okay.
Sorry.
No, it's all good. It's all good. Thank you. So, give me feedback, y'all. So far, maybe we should have done 5 minutes. But is there anything that, like, yeah?
I enjoyed the color coding and the very like visual. I could see exactly what you were doing because I'd imagine myself like as a sped student being like seeing all this data, being overwhelmed by it, and just kind of being lost as to what someone is saying. And you clearly, you know, these are the ones that are decreasing, this one's increasing, I mean this one's staying the same and this one's increasing. It's very visual and very organized, and I think that's beneficial for our sped students. I should write that down.
Yeah, thank you.
I think it was nice that you were specific about asking for detailed information about what changes there were, because the conversation could have easily just stopped at most of them decreased except for 2. But you were specific about which ones had the same pattern and which ones were different. So that way moving forward everyone knows exactly which data sets we're kind of talking about.
That's one thing that I work on in 5th grade is like general versus specific. I'm curious, I know we're all 8th graders, so that's probably why. But one question I have is my little 5th graders, if I ask them what patterns do they see, they would say like they're all around 130. So how do you get them from, or like they're all even numbers, or they go by 2s, but how do I get them to think about a relationship between numbers versus here's just a long list of numbers, what pattern do you see? Because they tend to just look at the numbers and like, oh, a lot of them went from even to odd numbers.
That's good.
Well, I think you would have to maybe give them some sort of vocabulary to use. like, you know, here, is it increase, decreasing, or staying the same?
Yeah.
Instead of just what patterns do you see for your kids? Right?
Yeah, that's what, when I taught patterns, we did the increase, decrease, stay the same, or I did like a sentence starter. Maybe I just see more practice on that. Sorry, that was off topic, I was just
No,
curious.
that's actually a really good point.
No.
Because I never, like, my 8th graders wouldn't even go there. They would already see the increase,
Yeah.
decrease, whatever, like you were saying. And so that makes me think, because I never do anchor charts, and that's something that I want to work on. Like, let's use our sentence starters or our vocabulary for seeing patterns in data, like pull from this chart. And I actually think, like you were talking about SPED students or just EL students, they could really benefit from, like, what words does she want me to use right now?
Oh,
Right.
that's a good idea. I should probably do, because I have a area in the classroom, I could do an anchor chart with that. That'd be a good idea, to like refresh from like, remember back in September?
Mm-hmm.
It's a good idea, thanks.
Any last things before we have someone volunteer for the next portion of the lesson?
Quick side question, they have these, like, is this something that they have in front of them as well, or are these numbers just on the board?
These, that's a really good point too, I should hand out. They only have typically this in front of them.
Okay.
So the their data, so before, after, and then 1 minute after. So
Okay.
like they're only looking at these numbers, and then I've usually I actually have them walk up to the chart and write them in, because no matter what period, typically the pattern stays the same. Like
Okay.
most of them decrease. So, it would be nice actually if they had this in front of them so they can make their own notes and things like that.
Yeah, because I'm thinking of like the low kids that when they go to look at theirs and they're already like, oh, why did I circle something? And then like, or have them circle on their data or something, so that way when they go home or if they're if they don't finish and they have to finish up at home, they have something to like refer back to.
Yeah, that's good. Okay, we're at 7:40 right now. Maybe we have enough time to do like 2 more people teach like little portions of the lesson, and then we give feedback, and then we can end there. So do I have any volunteers?
I'll go.
Thanks, Ms. Rita. Well, since you're next to it, do you want to switch or do you want to
No.
stay there?
Yeah,
you're
you're
good.
like, I
Okay.
bet someone's in here.
So do I.
Yeah.
Cool. All right. So does anybody remember why we did this lab? What was the purpose of this lab? What kind of law were we looking at when we did this lab? Anybody?
I'm pretty sure it was called the Law of Conservation of Mass.
Mm-hmm. Okay, so what does the law of conservation of mass say? Talk to your partners. Ask them if you don't remember. 10 seconds.
I have the notes from yesterday. I'm pretty sure that it says that things stay the same.
Yeah, like the atoms stay the same. I feel like it's like the atoms stay the same.
But I think, but not together the same. Like the number of atoms stay the same, but the way it's organized is different.
Okay, time. All right, does anybody want to volunteer to talk about what they discussed with their partners? What does the law of conservation of mass say?
I'll go. We talked about how the atoms stay the same, but they're not arranged the same. They're the same, but they change.
Okay, and now what about the weight or the mass of something? Should it stay the same according to the law of conservation of mass, or should it increase or decrease? What do you guys think?
I think it should be the same,
Yeah,
yeah.
same.
We said the same.
Okay, so because this lab was about the conservation of mass and things were supposed to stay the same, how come our data looks so different? What do we think is happening? What might have caused this decrease in not just one of our datas, but 1, 2, 3, 4, and then only one of our data shows that it stayed the same, and then the last one actually increased. What do we think? So talk to your partner and then for 30 seconds and try to figure out what is happening with our data.
I think they messed up the lab.
I know. I'm in the blue group. We did it wrong. Yeah.
There's always people who are so messy in my group, so I just think they messed it up.
Miss Rivas never listens. She never follows instructions.
Oh my gosh. Tell me about it in math.
We're gonna lose
All the time.
points.
All
We're
right.
gonna lose points.
We're gonna lose points.
Time. All right.
Miss Rivas is a student.
Does anybody want to talk about what happened in their group and in their lab? For example, Morgan, you were in this this lab right here in the blue. What happened that made your data increase? What do you think went wrong or went right? Maybe. What do you think?
Well, I don't know. I mean, we tried to follow the instructions, but maybe when I was putting the baking soda in, maybe I didn't get it all in there, or I did something wrong. I think I tried to follow the procedure, but my group may not have done. There might have been an error in our data.
Okay. Anybody who, Ms. Hirschberger, you were in the green group. What did you do in your lab to produce these results?
We just did the instructions.
Okay, followed everything.
But maybe like the other groups, maybe like there was like a rip or a tear in their balloon, so some of like the gas got out. Because I could totally see that happening. Or maybe they like spilled a little bit of the, I don't know.
They messed it up.
Okay, interesting. So,
Time.
Sarah.
Sorry.
All right.
Sorry, I really
I know,
bad.
it's
It
always
was
like-
like,
Perfect.
It has to be done. Feel free to take some
Nice
think
job.
time too, you guys. I didn't say that earlier. Like, yeah, nice job. Between like the teaching, like, cause I remember like as you're pretending to be students, you have to pretend to be a student and also try to reflect on like what Miss Rivers was doing. So it's like
Yeah.
if you need a time to think, that's totally acceptable.
All right, so feedback time.
I think it was nice that you didn't explicitly tell us anything. You had us go back to restating the definition of the law of conservation of matter, and then had us apply it to the data by just asking questions.
I was a little confused with your first question. I believe you said like, why do you think a lot of the data went down? And then it was like a compound question, so it was like, and why did some stay the same, and why did one get bigger? So by the time we got to the end of it, I was like, what was her original question? So for me, it's early in the morning, my brain is not awake yet. So I was like, wait, okay.
So
So
chunk
maybe,
questions
chunk it, like, okay, so why do you think it went down? Let's talk about that.
Mm-hmm.
And like maybe do one at a time, so that way kids can digest one pattern at a time, if that makes sense.
Mm-hmm.
But again, coming from the 5th grade babies that can't tie shoes sometimes.
I thought it was, I think the practice of, I'll let you finish writing.
No problem. I'm listening. I can do it.
Okay. The practice of like remembering who produced the data is beneficial. Because I like that you targeted that student, or that group at least, and asked them for reasoning. Because sometimes I think something is lost sometimes when we're just looking at numbers and like, what could have happened, right?
Mm-hmm.
So I thought that was powerful, that like, what did you guys do? Or what can you speak on behalf of this data?
Mm-hmm.
Yeah.
Because I think the kids are asking that question anyway. They just may not be saying it. Like, why don't you just ask the person who made that, or who came up with that?
Mm-hmm.
Yeah.
And then it holds them all accountable too.
How defensive do your students get when you're like, why did you guys go down? Or like, why do you think your data like didn't show it? Like, are they just like, it's not my fault, I did everything? Or like, they usually chill about it? I'm just curious.
I think oftentimes, I don't know, maybe it's the way of questioning.
Okay.
But I try to remove it from them. Like,
Mhm.
this is not personal at all. But I'm trying
Yeah.
to, because they don't usually react, they don't get defensive.
Right,
but
right.
maybe the 8th grader in them is just like,
Oh, my 5th graders don't get defensive. I was just
Yeah.
curious.
Yeah.
No, my 5th graders are just like, I did the lab this way because I don't want to lose points. And I'm just like,
I don't want to lose points, I want to get in trouble. I gave you what you wanted. Nice.
yes.
That's like, that's actually what I think happens here.
Is they're just like, we know it's supposed to be the
They
same.
know what the answer's supposed to be, and that's where like I catch them, and I'm like, I don't even know how you got that, because gas should have been leaking out the entire time, you know. So like,
Maybe they didn't wait the full minute.
They cheated.
Because I think a lot of, that's what I see in 8th grade most often, is more like skewing the data to give me what I want.
Yeah.
Versus like, no, I was trying to actually trick you.
They're more interested in the
Mhm.
gratification.
Yeah. Okay, well, it is 7:46, so do we have one more? Thanks, Mr. Rose, for your teaching. Do we have one more teacher who is willing to come up with, please?
Which part are we at exactly?
Still trying to get them to come
the
up with
helium.
the helium.
Okay.
Sorry, those helium balloons should say like latex balloons, like the latex balloons leak gas. So wherever you see helium, just think of latex, but for our purposes, you know.
I'll take over.
Do you want me to switch with you? Or
No,
you
I'm good, thank you. I'm gonna go to you though, because your last comment was about,
Yeah. Her last comment was
was about the balloon, right?
Yes.
Okay.
Root tear.
Okay, cool. So let's go back to Ms. Hirschberger. Can you explain why you said something about the possibility of the balloon tearing? What do you mean by that?
Yeah, so like if there was like a hole in the balloon or a tear in the balloon, some of the gas would leak out, and then it would go down, like when your car gets a flat tire.
Okay, nice analogy. So what does that mean about our law of conservation of mass or matter? What could have happened to, I don't know how to say this actually.
I have a question, Miss Anderson.
Mm-hmm.
But if our balloons were torn, then wouldn't they have not really inflated? I mean, I feel like I saw everybody's balloon inflate. So I don't know if I agree with Ms. Hirschberger.
Yeah, let's go back to Ms. Hirschberger. What do you think?
Well, it's like when you're like the tire popping on a car, it takes a little bit for it to like leak out. Maybe it just took a little bit for it to leak out, like, because I noticed in the pictures some people's balloons were really big and other ones were really small, so maybe it was just taking a while to leak out. I mean, it's not like it's gonna explode. Oh, that'd be cool. Next lab.
What do you think? Who do you agree with?
Well, my group was really careful. Like, I actually made sure everyone cut their fingernails the night before so that they wouldn't rip the balloon, because I love science. I don't want them to mess it up. So I still got this date. Like, my group still saw the mass go down, but we were so careful. So I don't agree. I don't think Ms. Hirschberger is right. She's saying we weren't careful, and we were careful.
So do you think that there's a possibility that there are any, not necessarily tears in the balloon, but areas where any kind of gas could have leaked out? Turn and tell your partner what you're thinking.
Maybe that's a possibility.
Do you mean like maybe between the balloon and the was it flask? Sorry, I couldn't see the shape. Okay, yeah, the Erlenmeyer flask. Maybe there was like a little like escape down that way. It wasn't tight.
So it wasn't tight enough.
Yeah.
It could be. It could be.
That makes sense.
Time's up. So, what did we come up with?
Well, Ms. Hirschberger thinks that maybe there wasn't a tear, but maybe it wasn't tight enough at the flask where the balloon was on, so maybe some gas escaped from there.
Okay. What about the balloon itself? Think about raise your hand if you've ever had birthday balloons.
I love birthday
I love
balloons.
birthday balloons. Raise your hand if you've been sad the next day because you noticed that your birthday balloon got sad too. It sunk down overnight. Okay. But see, was the string tied tight on the bottom of the balloon?
Seemed like
Yeah.
it.
Okay.
Yeah.
Okay, kind of like our balloon on our flask, right? So what other possibilities are there? Where else could there be a gap in the balloon? I don't know.
We did learn about polymers, the flexi things.
Okay. Tell us more about what you're thinking about that.
Well, I remember you teaching us a couple months ago about polymers and how they're like a flexi, like they're a flexi solid, but like they're what is it? It's like it can move.
Like, they do this.
Yeah, they like move.
I like what so let's take a look at what Miss Worthington is doing with her hands. So when she spreads them apart like that, what's left in between?
Space.
Okay. And so we're talking about there being a space. So maybe it's not necessarily a tear in the balloon, but what could be going on there?
It could be leaking through the space.
Okay.
Yeah, because the more the gas goes in there, the more it expands, and the more spaces you'll have.
all take a second just to do that with our hands. Create that little space there. Yeah, okay, cool. I don't know where I'm going with this anymore. Thanks for helping me out though, guys.
And time.
Sweet.
So there you go.
Thanks.
Perfect.
I needed that.
That's cool. I like how, if I just jump in right away,
Yeah.
I like, Morgan, how you brought it back to the habits. So like I think it was an interaction here, like why don't you respond to that, like Ms. Hirschberger, or why don't you like direct that question? It was like you put it back on them to speak to each other, which is something like I always try to get to do. Like I hate doing what is that called?
Volleyball?
I want the volleyball to happen versus like, what's the other analogy? What's this one?
The ping pong one.
Yeah, versus like ping pong between the teacher and those two. Okay.
I have a quick side question. Can we get a list of these habits of discussion? Because I've heard a lot about it, but I know nothing of what they are. I've never heard.
You just did it.
I did.
So that would be awesome if I could get like the list of what they are, because I think I missed stuff. Because everyone talks about it.
Yeah, these
I'll
buzzword,
make
right?
you a copy of this. This
Did
is
you
the
send-
handout
did
that
you
they
send
gave
it?
us.
Oh, that was the day I left early because of a migraine.
Yeah, I don't
Yes.
think
Okay,
That's-
yes,
that's
that would be
what it
awesome if I could get a copy
Yeah,
of that.
I'll make a copy of that.
Sorry.
So Morgan, you'll do that?
Mhm.
Thanks.
I also like the kinesthetic. You know, everybody do that. That was really cool. You know, because
Thanks for helping with that. I didn't need to.
because I think kids like that. You know, they make connections based on their movements or repeating, and I think that's really important. So
I also like how you connected the like tightness on the flask to the balloon being tied. So that way, like, it wasn't just like a jump, like, oh, we have a balloon here, we have a balloon there, but like, you took what we thought was happening and applied it to that example, which I think is really powerful, because then they're like, oh yeah, that was tight on tight. So even if that was tight, like, so they can make that connection, yeah,
Thank you. Yeah.
I liked it a lot.
I don't know how accurate it was because you guys definitely helped me out of there, but it's like, ooh, because now they're getting into this misconception of like, ooh, because that's what I would do as a student probably is think that it had to do with how tight the balloon was around the flask, rather than the porous nature of the balloon. So thanks for the polymer. I was like,
Yeah.
That was
I was like,
Because I know you taught that already.
oh, so that okay, cool.
Yeah, they should have like, they have that somewhere.
That prior knowledge somewhere. Okay.
Um,
So that was good.
I remember when we looked at your Quizlet, you had polymer in there, that's how I knew.
Oh,
Because I knew you've already done it on Quizlet. So I was like, oh, they learned about polymers.
yeah.
They can bring that.
Okay, cool. We'll pause there because I want you to go back with a little bit of time before 8 o'clock to get anything settled in your homeroom. But since you took notes, Ms. Rivas, could you highlight some of the things that like we thought were strengths or things that like we think we need to work on?
all right. So we like the visuals and the color coding. Details about patterns, which ones increase, which ones decrease. We do think that an anchor chart would be beneficial for our SPED students and for like our little ones. We like that there was no kind of explicit stating, we just kept asking questions and keeping the conversation going. But we did say that we would like more chunk questions versus long questions of series of questions so that the kids can digest one pattern at a time. We like the connections made from, what is the data saying and what did your group do to make those connections as well, giving them some accountability. We liked the kinesthetics and the kids speaking to each other versus speaking to the teacher, and then making real world connections like birthday balloons versus, what we did in the lab.
Okay. Let's see. Would you be cool with typing up that list, Ms. Rivas? And just like emailing it to us so that we have like we know what we can apply in future lessons. And then, yeah, that we will stop there. And just like in a minute or so you guys can get back. What did you think of the teach back protocol?
That was cool. I like.
Yeah.
I see your different style of teaching, and it's
Yeah.
cool.
I like it.
Yeah.
I think it's kind of like a mini observation.
Mm-hmm.
Like if you don't always get to go to the teacher's class, you can see kind of what they would do.
It definitely requires you to think on your toes, because like looking at this, it's like we're looking at. I mean, it's got like a kind of an interesting duality. Like it's kind of intimidating to read something that you didn't write because it's like I was afraid that I was gonna mess it up somehow, like that I was gonna get stuck because I didn't really know the lesson as well. But at the same time, it gives you like fresh eyes and hearing someone else. I can imagine that hearing someone else reading my lesson without having written it would be kind of enlightening to see how they interpret the lesson plan and what they kind of like do with it. So I think it's just an interesting kind of thing to observe and to do as well.
Right on. And I will make one note in response. This is like probably a little too scripted for what a teach back should be. I'll show you guys like another sample teach back lesson plan where the teacher just actually listed the questions she was going to ask the students, and she let it be more free flowing. Like, what are the kids going to say versus like, here are some possible student responses. So that's like another thing we can try too, because I think it might be overwhelming trying to read all of that while trying to teach it, while trying to be a student. So
I think it just depends on your style.
Yeah.
I was gonna say it also depends on who you're doing the teach back with, because
Yeah.
if you throw someone, like if they don't have science background, they might come up with a lot of random things like the kids do. But since we all have a science background, we're all kind of like, well, we know the answer. Like, you know what I mean? So it's good to see the other things. Like, I know a couple things what my 5th graders say, which are not the same as like the 8th graders. So that was cool to see kind of what's expected. So maybe, I know it would be a little bit more, but like somehow if the students get stuck, like give them like, well, here's some answers that like I've been given, like that type of thing, so you can try to let it be organic. But then if people are like, yeah, we all came up with this one idea, and you're just like do you just roll with that one idea, or do you want more to come up, I guess is the question. Yeah.
So yeah, the student responses could be helpful, especially if I don't know how a 5th grader would respond.
Because like this like we don't go over polymers in 5th grade, so that jump that we got there wouldn't happen.
I actually don't know if the kids would have made that connection, but
Anyways, yeah.
yeah.
Okay, sorry.
Yeah, I was like,
No,
that's,
no,
I was like, that's pretty advanced.
There could be one kiddo.
Yeah,
who, like,
maybe one, but
reaches.
it's
Yeah.
like,
Yeah.
yeah,
But would they say it? Like, would
Yeah.
they raise their hand and give it? Yeah.
exactly.
Okay.
Sometimes they don't make those
Sorry, I
connections.
was thinking
Sometimes,
adults.
sometimes you have to kind of probe it. Like,
Yeah.
oh, let's think about polymers. Like,
Yeah.
what do we know about them? And
Yeah.
then they would come up with that.
They'd be like,
answer.
oh,
and then you
yeah.
make that connection.
Yeah.
Yeah, because otherwise it would be very hard to go from that misconception of like, oh, it must be coming from the bottom versus like it's in the the gaps are in the material itself.
You started to lead that though when you were like, okay,
Where
what about the
else?
balloon?
Yeah.
What do you know about the balloon?
But yeah.
And then I think, Sarah, you showed a picture of the structure of the balloon. Right.
Yeah, like
Oh,
in the
right, in
but
the
it's
lesson.
it's locked. But yeah, I didn't
Oh,
show you guys that was available. I was more like, let's just wing it. But yeah,
Yeah.
they do have a picture of what the pores look like. Cool.
But to Heather's point, it's like, what do you do if there is like that one kind of thing that people did, like either way, like either there's one misconception that everyone kind of agrees upon, and then how do you face that as a teacher, or what if like everybody's just totally different places and we can't like come to any kind of conclusion. So it's just the student responses are always going to be a surprise. So it's like,
That's true.
yeah.
And that's like the beauty of the teach back. It's like, how would we respond? Like, what would be a
Yeah.
good strategy in responding or
Yeah.
gathering
So
all
it's-
those different ideas and doing something with it?
So it's interesting.
So we'll end here, you guys. It's 8. You guys all start at 8:05, right?
Yes.
Okay, cool. Thanks again, you guys, for your time.
Thank you.
I appreciate you very, very much.
Thank you.
Yeah.
Thank
Does
you for the
anyone
coffee
know?
very, very much.
Oh, you're so welcome.
That was lovely.
Is Andy in your room? Do you remember it all?
I believe
Never
so.
got
He
his
has.
coffee.
Oh, you want? Yeah.
Would you know?
Not at all. I believe he was in my room.
Spill over
over to your room and see if you have some.
Oh, yes, yes.
Oh, and can I go to yours and get those?
Yeah. Do you want me to deliver them? That way you can just get
Sure, with the
started.
Student.
Yeah.